This video is just a bit more detailed introduction to inverse functions. So I've already touched on the fact that functions may be represented both algebraically and graphically. Now, you're used to that. So ordinary functions, we have the algebraic equation, and we also have the graphical form. We sketch the graph of the functions. Inverse functions, they're going to be the same. We need to be able to write them in algebraic form, and we need to be able to sketch them. I touched on this in the first video, that if a function is y equals function of x, then its inverse is f to the minus 1 of x. And we read it as f inverse. That little minus 1 I will refer to as inverse. Like I said, you've seen it before in trig equations. It's really important that you get used to calling it inverse and be aware that it is definitely not 1 over f of x. If we want 1 over f of x, then we've got to write f of x all to the minus 1. Now, it is going to be confusing, especially when we get to trig, because we've seen that we can actually put, in a trig function, we can put a power in here, and it behaves exactly the same as the power on the outside. So sine squared x, we don't write necessarily as sine x, all squared. We actually put the 2 in here. When it comes to this minus 1 notation, it doesn't behave in that same way. So, algebraically, to obtain the inverse function is really simple. You swap your x and your y values. You just swap x and y. So y equals x cubed, then swapping the positions. Put the x here, so put the x at the front, put the y in the x spot, and you get x equals y cubed. They're called inverse functions of one another. And you'll see in a moment why I didn't choose y equals x squared. You'll see that in a moment. So, yeah, to obtain an inverse function, the algebraic form, just swap x and y. The graphical representation, so there you've got y equals x cubed, the original function, and its inverse, x equals y cubed, which we're not very familiar with plotting, and possibly the easiest way to plot some of these graphs is to understand that the inverse function is a reflection of the original function in the line y equals x, and to create the graph that way. It's not too bad here. I would strongly advise that if you're doing that way, that you keep the same scale on each axis, which becomes really difficult when we're doing sine and cos curves, but you'll get to learn what they look like anyway. The inverse functions, and like it's saying there graphically, the inverse functions are a reflection of one another in the line y equals x. And we do lots of graphing, so you'll get quite used to that. Some functions don't have an inverse function. So while we could consider y equals x squared, and algebraically we can create x equals y squared. X equals y squared is not an inverse function, because remember, for something to be a function, it must pass the vertical line test. This graph here, not passing the vertical line test, it's not a function. Definitely not a function. So this is a function, y equals x squared, passes the vertical line test. It is a function, however its inverse is not a function. Now, the way we can tell from the original function is by simply applying now a horizontal line test. So if our original function fails the horizontal line test, its inverse won't be a function either. So it's pretty straightforward, and you can probably see now that those sine curves, cos curve, tan, because it keeps repeating, they strictly speaking, for you to, well, if we just consider the whole of the curve, whole of the function, the inverse is not a function. But we're going to see how we can create an inverse for sine, cos and tan, and that will be by restricting the domain. And we could even consider that here. If I restricted the domain to just x values less than x, and I didn't have this branch, so I'm restricting the domain, you could see that we would just create the top part, and you could say that the inverse function does exist. So there it is. So we've restricted the domain to x is less than or equal to 0, and it creates the bottom part. And some features are x is less than or equal to 0 and y equals x squared, or y will always be a positive because x squared is always a positive. And the domain is this negative one. Sorry, the inverse is the negative branch. So they look like that. And again, this I would discourage you from creating scales like this. It doesn't make it so easy to see that one is a reflection in the line y equals x. So make the scales on each axis the same. So this more realistically should be 1-ish. And then we go 2 and so on. So if f of x is 3x plus 4, the inverse function, step 1. Step 1 is, when it's written in this format, you've seen it before, just put a y in the spot for your f of x. So then swap your y and x, and then make y the subject in your new inverse function. So y equals 3x plus 4, swapping the x and the y, you get x is 3y plus 4, then you get 3y is x minus 4. Now we've got to make y the subject. Whoops. And you can almost see there that, we've got y is equal to x minus 4 all over 3. That over 3 has been cut off for you. So then we replace the y with our inverse function notation, and it's x minus 4 on 3. Let's have a look at another example. If f of x is equal to the log of x to base e, find the inverse function. So step 1, replace f of x with y, which we've seen lots of times before. Now, step 2, swap x and y. So x is equal to the log of y to base e. And it's, we're just going to recall the rule, or the definition of log of a number to a given base is equal to the power to which that base needs to be raised. So we'd have e as the base, x is the power, y is the number. And so it looks like this, x equals log to base e of y. Then use the definition that the log of a number, so this is our number, y, is the base to this power. And we've got the y is equal to e to the x. We know that's called the exponential. So we started with the log function, and we end up with the exponential. So one is the inverse of the other. If you've got f of x is log of x, then the inverse function is e to the x. So y equals e to the x. It's interesting to look at these. What do we know about that as a function? It's a function. It passes the horizontal line test, and that's why its inverse is also a function. The domain is all real, all x values, no restriction on the x's. However, there is a restriction on the range. It's y is greater than 0. Let's have a look at the inverse, the log function. The domain is x is greater than 0, x is greater than 0, and the range is all real y values. So what we actually see is there's swapping. What was the domain of a function becomes the range of the inverse. What was the range of the function becomes the domain greater than 0 for the inverse. And I'll stop the video there.